The main motivation of this talk, though, is to also get you to understand how parachains work, because parachains are by far the newest technology we've been talking about, and afterwards we'll have a panel for which it's ideal if everyone at least has a basic notion of how a parachain works. So it will be like 15, 20 minutes, maybe. So if you have questions during the talk, just like raise your hand and we can do questions during the talk, especially about the parachain stuff, because it's important that everyone understands this. Yes, so that's pretty much the introduction. So you want to build a dApp, right? And currently when people think about, oh, let's build a dApp, everyone thinks about, let's write a bunch of facility, deploy smart contracts, and hope that the shit doesn't break. Which realistically it always does somehow break, because we have no good mental models on how we can actually have scalable auditing of facility code. So one of the very secure multi-sig vaults in Solidity is written by Gnosis, and the way they audited it, they essentially stepped through the entire bytecode line by line and looked at what was on the stack and what was happening in the execution trace. It's like, fundamentally right now, if you want to deploy a dApp, most likely you cannot deploy it on Ethereum because it's way too expensive to audit. Like, the auditing costs are astronomical to actually be able to. The auditing cost almost scales with the value of your dApp, right? If you want to deploy a $10 million dApp, you probably need to spend $5 million on auditing it. So it's probably not a good idea to build very complex state machines on the EVM. Yes. So what is a smart contract? A smart contract is this very cool this very cool feature that allows anyone in the world to deploy a fully permissionless system, right? Like Facebook could go out tomorrow and issue a stablecoin on Ethereum because they can prove that they actually don't have any control over it after they've issued it. And for that, smart contracts are fantastic. So smart contracts are this fantastic permissionless thing that will run in perpetuity, that ideally should be correct and will get executed according to what the code says it does. And so also, most people seem to now, when we say smart contracts, seem to think of the EVM. In this context, so I'll talk a lot about the Ethereum ecosystem here in the EVM, but generally when I mean smart contracts, I mean any sort of permissionless, deployable, metered state transition function, right? So a smart contract can run out of gas, and that's what I mean by metered. But you can have smart contracts on something like RSK, Ethereum Classic, Edgeware will have smart contracts that are also metered. But like the fundamental feature is that anyone can deploy them, and they're somehow bounded in computational complexity by some amount of metering. So what is a parachain? A parachain is a WASM blob. It's a WASM blob that implements a specific outwards facing API. So there's, for example, you can sort of imagine like writing a library that has to adhere to an interface. So this WASM blob has to adhere to the Polkadot runtime interface, where you, for example, have to implement a function called execute block or a function called finalize block. And then the runtime environment, which Edward was talking about, will call into this WASM module to execute those functions. These modules, so they're called parachains, by the way, if in the context of Polkadot. So Polkadot has parachains. So you could have WASM modules for other blockchain systems. Like EOS also uses WASM, but those aren't parachains. Those are, I guess, actually smart contracts to some extent. And the cool thing about parachains in the context of Polkadot is that they're unmetered. So you can have extremely complex state transition functions. So for example, you can build these extremely complex DEXs that have on-chain order books, on-chain order matching, and you never have to think of whether you're running out of gas in a state transition you're doing. A parachain is sort of like you build your own blockchain, but you don't have to worry about your own security. So parachains, we'll also talk about this later, are fundamentally the notion that you have the shared security mechanism where when you want to build an independent blockchain, you all of a sudden have to start worrying about how do I secure this? Like who will be my validators, who will be my miners, how valuable is my token, how valuable am I against takeover attacks? But within a parachain context, that sort of complexity goes away. You don't have to worry about how your chain is secured. You just trust the Polkadot validator set that they're secure to chain. And the next cool feature is interoperability. So between all parachains, you can do message passing. So between independent blockchains, you usually call this IBC, inter-blockchain communication. So between different consensus systems, you have IBC communication, inter-blockchain communication. But between parachains, right now, the notion is called message passing, so that one parachain can send a message to another parachain. And those messages are fully asynchronous. And actually, so fundamentally, the cool thing about this is the reason why Ethereum worked was because Ethereum allowed interoperability between different state transition functions, right? You could have a token contract that interacted with a wallet contract that interacted with a, let's say, exchange contract. So you could have, you take your Aragon token, you move it into a Gnosis multisig wallet, and then from the Gnosis multisig wallet, you send it into Ether Delta, where you then trade it. And so this interoperability feature is one of the killer features on Ethereum, because it allows other people to build very interesting applications on top of more basic primitives. And you have the same thing with parachains. So with parachains, you don't build on other people's smart contracts, you can interact with other people's parachains. Right? So let's say we have some sort of fiat issuance zone, parachain, where like one of the best examples is a company in Denmark that are trying to issue digital Danish crowns on the blockchain. So they would have one parachain where you send them one Danish crown and they give you an e-ride to this Danish crown. And afterwards you can take this Danish crown and trade this, move this over through message passing into a different parachain that's, for example, a DEX. And on that DEX you can then start trading with this digital Danish crown against some Ether. And then, right, you see what I mean? Like you can start building across multiple different parachains. Yes. So those are sort of like brief introduction to parachains. I will talk much more in detail on how they work in like the same slide that Edward showed. And this one. And then we have independent blockchains. Traditionally, like until Ethereum came around, it was extremely difficult to build any sort of decentralized application, right? Like what were your choices? You could fork Bitcoin, which like companies, like projects like Zcash did. And that sort of sucked because you now were stuck with this incredibly old legacy code base that you really couldn't change, and it didn't buy you a lot of features. The other problem before that was when you wanted to do this, you sort of had to bootstrap your entire ecosystem, and that's also something that Ethereum's interoperability got rid of. So, but nowadays, we actually have much better tooling to build our own blockchains. We don't have to fork Bitcoin anymore, and we also don't have to fork Ethereum anymore. We can use something like Substrate, where Substrate is the software development kit that allows you to build extremely quickly build fully independent blockchains, right? You get consensus out of a box, you get networking out of a box, and you have this very clean API that allows you to just focus on building your state machine, so that you don't have to think about like 70 to 80% of the entire blockchain stack. So you don't have to think about networking, you don't have to think about consensus. To some extent, sometimes you don't even have to think about the user experience, user interfaces on top, if there's some sort of common API layer on top of the state machines. You only focus on what makes your blockchain unique, which for most people is really going to be the state machine. So for example, Substrate would allow you to very quickly deploy something like Zcash. So you take a basic module, and that's also the other cool thing about Substrate, there's a module system, so you can take modules that other people wrote and integrate them into your own chains, so that if, let's say, Parity also built a governance module, you don't have to reinvent governance from scratch. You just take the governance module, you take the account module, you write your own privacy module, and all of a sudden you can deploy something like Bitcoin or Zcash in maybe 500 lines of code, right? Just think about how powerful this is. You don't have to do, you have to write 500 lines of code in order to get Zcash working. Maybe to get Bitcoin working. Zcash is probably going to be a little bit more and requires more engineering. But to get Bitcoin working is maybe like 500 lines of code, and that's something that realistically someone can do in a hackathon, right? Like someone can rock up over the weekend, 48 hours, build the next Bitcoin, and like on Monday be able to deploy it. Because once you've built it with Substrate, you can also deploy it as a parachain into the shared security context, where over the weekend I can develop the next Bitcoin and deploy it into Polkadot, and within like 3 days I have a fully functioning blockchain. Yes, so now we'll talk a little bit about how Polkadot and parachains actually work. Okay, so you see these big circles are effectively the relay chain. So this is a bunch of validators, and initially this is not yet capped in Polkadot. This may be capped in the future, capped in terms of the number of validators. But let's assume there are 200 of these, right? So there are 200 of these relay chain validators, and all they do is they validate the relay chain. But then people are also able to deploy parachains. So a user on the relay chain, sends a transaction that includes a blob of WASM. And since these guys all have a WASM VM, they can all start running this WASM code. We may have to have some permissioning scheme on who is allowed to deploy this and whether governance has to vote this in. But effectively, I as a user say, I want to deploy my parachain. I send a transaction to one of these guys. They gossip it through the network. They come to consensus over it. And now this parachain is starting to be live. And then what the relay chain does, the relay chain assigns a subset of its own validators to validate this parachain. So imagine we have 200 relay chain validators. Let's say every day, we randomly take 5 of those guys and say, you 5 guys are responsible for validating this parachain. So you're responsible for including a commitment to the state root of this parachain into the relay chain blocks. And the question becomes, how do these 5 guys that can switch every day get all the information on what is a valid block, what are the transactions, right? Because users can't rely on these guys to sort of always be around and always be able to send them transactions. So this is where you have something called collators. You can think of collators sort of like full nodes, but full nodes that do a little bit more. Full nodes that also, yeah, you can think of them like full nodes. They're essentially they always run the same parachain. They never change the version of the parachain they're running. They never run a different parachain. They only run this one specific parachain. They're essentially they're full nodes for that green parachain. And given that I as a user can send, I want to transact on this parachain, let's say there's a Zcash, like a Zcash-like parachain. So I send my transaction to one of these collators, and maybe 100 other people send their transaction to one of these collators. And then once it comes time for the relay chain, for the 5 relay chain validators that are supposed to validate this parachain, one of the collators, or all of the collators, will send their block. So these collators create what they think are valid blocks and what they believe are valid blocks, and they send that block to one of the relay chain validators, one of their relay chain validators. And then the relay chain validators run the state transition function to make sure it's a correct block with correct state that actually correctly executes given the WASM blob that I initially uploaded to run this parachain. And if that's the case, the relay chain validators will start to include this in the relay chain, and by including in the relay chain and then waiting for the BFT for Byzantine agreement to happen over that relay chain block, will eventually finalize it. By the way, if you have questions on this, please raise your hand and I can answer them now. Otherwise, you can also answer them later. So this also introduces a little bit of complexity, like what happens if one of these collators is malicious and submits a malicious block, and these guys don't properly check this because it's expensive to connect to everyone. Crap. Wait, no, it's locked. There we go. So that's why we have a concept called a fisherman. Fishermen are essentially incentivized to try to figure out if any of these participants cheat, because if they cheat, and they can prove that they cheat, because all of these, okay, so this entire scheme, as in almost all blockchains, is secured by attributable signatures. So if one of these collators creates a block that's faulty, he has signed this, I know which public keys, public identity signed this block, and afterwards, if I figure out that he did something wrong, I can slash him. So these fishermen are incentivized to be in the ecosystem and figure out if anyone is cheating, because if they can prove that someone cheated, they will get a lot of money. And so this is quite interesting. In Tezos, we also have this concept like a fisherman, and this happened like in the last 2 days. A large exchange had a backup node that was running at the same time as their main node, and they lost like 30 grand on security deposits due to that. So, but like in Tezos, effectively everyone is a fisherman at the same time because we just propagate information on wrong signature, on like faulty signatures. And you had a question over there. Yeah, so what happens if collators are censoring so the question was, what happens if all the collators censor a specific user, right? There is fishermen cannot protect you against this. So if there are schemes where if collators are censoring entire blocks and sort of preventing anyone from creating proofs over these blocks by withholding the data, we have a way. Al has been working on this to sort of like either make sure that that if the block is ever finalized, enough of the relay chain validators hold enough of the data to reconstruct the full block, even if all the collators withhold it. But yeah, in your own blockchain, like if all your validator set is malicious, you can be censored. Yep. No. So yeah, that wouldn't scale. So these guys, they don't have to maintain the state of every single parachain. They only have to maintain the state of the parachain they're assigned to validate. And so the 1 day example was a bad example. In reality, this is more going to be like month. So every couple of months, I may be assigned to a new parachain, and then I have to ask the collators.
So the idea is that validators that are assigned to a parachain, they're going to be like clients. They're not going to have the entire data for the chain because they're going to rotate reasonably quickly. But the collators are going to provide a like client proof along with a block that the validators are going to check.
Cool, thanks. Any other questions? Cool. Yeah, and so we talked about this concept of bridge chains, which is essentially we can build sort of finality layers around. So we can build finality layers around non-finality chains like Ethereum to be able to have them interact and have some sort of set of authorities be able to submit the latest block which they believe to be finalized into the relay chain so you can interact with with non-final chains. How far did this jump? Yes, okay, cool. Yes, so as a quick recap, because I think it's time for the panel, it is. So smart contracts written in Solidity, Viper, or Michelson, or EVM bytecode. The 2 main points are essentially we have metered execution and synchronous calls between different smart contracts. Usually they're permissionless to deploy. And they also derive their security from the backing of the underlying consensus system like Ethereum. Parachains, on the other hand, are written in a higher level language like Rust, C++, or Go, or any language really that you can figure out how to get to compile to WASM modules. You have asynchronous calls between parachains. The execution is unmetered, so there's no notion of gas, which allows for extremely complex state transition functions. In Polkadot specifically, the deployment of parachains may be subject to sort of governance approval, that governance won't be running like arbitrary parachains. So if you just like hack together a really shitty parachain, you may not be able to convince the validator set to actually run that. And they derive their security from the underlying consensus set of Polkadot. And then independent blockchains. So like you can essentially see the trend, right? This is like very limited, a lot less limited. Oh, this is a lot less limited, and this is sort of you can do whatever you want. You can pick any language. You can just build a blockchain. You can pick any consensus system, but at the same time you have to figure out how to actually secure that. Actually, I may skip the part on inter-blockchain communication, except that interoperability is the thing that's really cool because it allows us to compose different applications or state machines. And it also allows us to sort of connect to the legacy systems as well as connect to all the future chains. but it requires deterministic finality on each side. Right. In the beginning, most likely what will happen is that like the easiest sort of use case to figure out is how to do interoperability of tokens, but there's no reason why this shouldn't extend to NFTs or any sort of other interesting contracts. We can even have things like asynchronous contract calls between parachains. So like interoperability is really the key of the game because it will allow us to unlock a lot of value in this ecosystem. Use cases and examples. So parachains, so like actually smart contracts are super cool for like actual binding contracts. So something like extremely low volume that you want to live for a very long time, or something like multi-sig wallets. Parachain on the other hand are cool where you, for example, want to build a complex deck, so you want to have some e-money zones that sort of are able to issue pegged fiat currencies. And then independent blockchains are sort of anything where you have a concrete community that wants to have full control over what they're running. Questions?
Hi, thanks for that. Is there any advantage or incentive to use Polkadot if you wanted to run a federated independent blockchain?
You would want to bridge into Polkadot to sort of be able to transfer assets from Polkadot into your federated blockchain, and to allow users of your federated blockchain to actually interact with the rest of the blockchain ecosystem.
Okay, and given that a parachain can have its own internal token and it has collators and fishermen, what's the actual primary incentive for a parachain to exist on Polkadot? Because in theory, the collators and the fishermen, they need to have some incentive, right? So there's some staking going on the parachain, right? In order for the collators to act in the interest of that parachain.
Mm-hmm.
So presumably you'd need either you'd use the global token or you'd create your local token on the parachain, right? So
Absolutely.
If you create your own local token, which is quite likely, then you're staking that token to incentivize nodes to come in. What then is the reason for the integration with Polkadot?
Because even though you may issue your own token, you may not want to bet the security of your system on that token. So even if you have a staking token on a parachain where collators, let's say, need to stake their tokens, you may still want to benefit from being in this larger ecosystem that provides you larger security guarantees around your chain.
Hi, thanks for the talk. I was wondering, can you have different settings for the different parachains, as in how many validators they can take from the relay chain? How often do you change the frequency of these validators? And how does that work? No, you can't.
That's determined on the relay chain level. You don't have any control over that.
Yeah, pretty much.
Right? Yeah.
That's about right. So we'll kick off the panel as quickly as we can. I guess Alistair and Andrew, if you want to head up.